Now imagine a world where every single Python developer has their own writing style, their own way of writing the syntax of Python. Now this could become very confusing. If we run into an error in one of the programs, we'd have to dive into their code and try to work out what's gone wrong. So by following standard Python conventions when writing our code, we can make it easier for others to understand our programs, as well as for individuals to understand others' programs. So following best practice is always advised, for example including things like comments and docstrings in the code. And fortunately for us, we're able to follow the PEP 8 style guide for Python, which enables us to write cleaner code. So on screen here you can see the PEP 8 style guide, and on the left hand side we have the table of contents in which we're provided with best practices and styling conventions when writing code. So as a programmer, we should make our code as readable and understandable as possible. And to address this solution and make sure that our code does follow the PEP 8 style guide, Python provides us with a module known as Pylint. And what Pylint will enable us to do is assess specific scripts that we write and get feedback on how good our code is. So for example, Pylint could give us a list of errors which occur after the execution of the code. It takes a look at the code styling and then tries to enforce a coding standard, which means that everybody writing code scripts who utilize PEP 8 would have a very similar look and feel for their code styling. Pylint will also suggest how particular blocks of code can be updated, and can also provide us some details about the code's complexity. Now Pylint isn't the only tool that we can use, and it's very similar to packages like PyChecker, PyFlakes, Flake8 and MyPy. But for this video, we're going to take a look at how Pylint can help us improve our code. So let's first of all open up a blank file in Visual Studio Code, and we'll save this file as example.py. And what this module will do is simply produce a tax calculator. So we'll start by creating a variable called tax, which is set to 10% or 0.1. And seeing as this variable will always be 0.1, this would also be referred to as a constant, as we saw earlier in the course. We can then define a function. So we'll create a function called tax_calculator, and we'll then put a set of parentheses, followed by a colon. We'll then create a variable called salary, and we'll set this equal to an input function in which we ask, what is your salary? We can then wrap this in the built-in int function to convert this to an integer. We can then create a variable called tax_to_pay, and we'll set this equal to salary multiplied by tax. After this function definition, we will then call upon the tax_calculator function, and then we will print the value that's stored in tax. So in order to use the Pylint library, we need to make sure it's installed on our system. So if I go to my Anaconda prompt and then type in pip install Pylint, you should then start downloading the library accordingly. In my case, I'm told that the requirement is already satisfied, and that's because I've already installed it on my machine. What I can now do is utilize Pylint to check the example.py file that I've just created. So to do this, I'm going to first of all navigate to where the example.py file is located, and then I'm going to type Pylint followed by a space and then example.py. When I run this line of code in the terminal, you can see that we get the following feedback. We're first of all told that we have a missing module docstring, and therefore if someone was to come into this module, they wouldn't have a docstring that they could look at to gain more information as to what the module is intended for. Secondly, we can see that we've got a constant name tax, and it doesn't conform to the upper underscore case naming style. So it's giving us feedback that we should change this variable to capital letters accordingly. Thirdly, you can see that we're getting feedback telling us that we have a missing function or method docstring. And that's true. In example.py, we simply have defined a function, but we haven't given the function a specific docstring. So we can also add this shortly. And finally, you can see that we've got an unused variable called tax_to_pay. And that is also true. When we look at the file, we've defined tax_to_pay, but then we don't do anything with it. We're then told that our code has been rated 3.33 out of 10. So let's go back to our code file and take some of this feedback on board. So we'll first of all add our module docstring. So at the top we'll start and end triple quotes, and inside the docstring we'll put a module to calculate tax. So if I now save this file and then go back and run Pylint and then example.py, you can see that we've now corrected the missing module docstring, so it's no longer feedback for us, and our code has been rated 5 out of 10, whereas previously it was rated 3.33. So a slight improvement, great. So we can go back and we can also address the tax constant. So we'll now address the second issue, which was the constant named tax. But before I do this, I just quickly want to check PEP8 to see what it means. So if I go to the style guide and scroll down to where it says constants, you can see that we've got guidance that states constants are usually defined on a module level and written in all capital letters with underscores separating words. Examples include max underscore overflow and total. Okay, great. So this feedback now makes sense to me because I know that Pylint follows the PEP8 style guide. So we can now go to tax and we'll change this to all capital letters. And by doing this, I'm also going to need to change the reference to this variable to tax in capitals. So I'll change this tax to be in capitals, and I'll also change the bottom print function, which calls upon the tax variable. Okay, great. So we'll pause on that for now. We were also told that we had a missing docstring in the function. So what we can do is also include a docstring within the definition of tax underscore calculator, and we'll simply put the main function for calculating tax. So this should address the missing function docstring feedback, and we were finally told that we had an unused variable called tax underscore to underscore pay. And obviously because this stores the main result that we are calculating, i.e. the tax that an individual has to pay based on their salary, we want to return tax underscore to underscore pay within this function definition. If I now go back to my terminal and run Pylint example.py, you can see that our code has been rated 10 out of 10. There's no feedback for it to give us based on what we've currently got, and our code is conforming to PEP8 style guide. Now one thing to note here is that getting a 10 out of 10 rating is extremely difficult. You don't necessarily need a module to be rated 10 out of 10 for the module to work, but it is good practice to try to get this rating as high as possible to make it easier for others to understand your code when it comes to readability. So to summarize, Pylint is basically a static code analysis tool, and it helps us to identify errors in Python code, which helps then programmers enforce good coding style. So when it comes to debugging complex code, Pylint can be used, which means that there's less manual work when it comes to identifying the specific style guide conventions. The coding style that Pylint adopts is known as PEP8, and we saw PEP8 earlier. And based on the quality of your code in a specific module, you're given a rating out of 10. And you want to be as close to 10 as possible. Now the rating can actually be negative, and if we do get a low score, just remember it doesn't mean that our code is wrong. It just represents how understandable your code would be to another programmer. You'll be given some feedback on screen, and each feedback starts with a specific letter. So you can see here we're given some message objects which start with a C. And C stands for convention, and conventions are displayed when the program is not following the standard rules, so you might want to update these. You can see we also run into a W message object, and W stands for warning. So if you're given a warning feedback, it's displayed for Python specific problems. In this case you have an unused variable called tax to pay. You may also come across errors which would start with an E. You could have something which starts with an F which stands for fatal, which essentially means that Pylint has no access to further process that line of information. And you may also be given feedback which starts with an R, which stands for refactor. And this basically means the code doesn't quite sit right with Pylint. It's likely that it can be written better, so go back and give it another go. So try to get into the practice of running your modules through Pylint once you're completed with them. Others will thank you for it, and it just makes you a more consistent all-round Python programmer.